Introduction. Climate change is one of the most significant challenges facing humanity in the 21st century. Over the next century, the Earth's climate will undergo profound transformations due to a combination of human activities, natural processes, and technological advancements. This narrative envisions a future where global cooperation, innovation, and adaptive strategies shape the trajectory of our planet's climate. While challenges will undoubtedly persist, a combination of resilience, ingenuity, and commitment to sustainability will drive progress toward a more stable and equitable world. Global emissions peak. By 2025, the concerted efforts of countries around the world lead to the peaking of global greenhouse gas emissions. This milestone is achieved through a combination of international agreements, such as the strengthened Paris Agreement, and the implementation of aggressive emissions reduction policies. Renewable energy sources, including solar, wind, and hydroelectric power, account for a significant portion of global energy production, reducing reliance on fossil fuels. Additionally, carbon capture and storage (CCS) technologies begin to be deployed at scale, capturing emissions from industrial processes and power plants. Massive reforestation initiatives. By 2030, massive reforestation and afforestation initiatives are underway globally. Governments, corporations, and non-governmental organizations collaborate to plant billions of trees, restoring degraded landscapes and enhancing carbon sequestration. The Bond Challenge, which aims to restore 350 million hectares of degraded land by 2030, is surpassed, leading to improved biodiversity, soil health, and water cycle regulation. Urban areas also participate in greening efforts, with city planners incorporating green spaces and vertical gardens into urban design. Breakthroughs in renewable energy storage. In 2035, breakthroughs in renewable energy storage revolutionize the energy landscape. Advanced battery technologies, including solid-state batteries and flow batteries, provide efficient, long-duration energy storage solutions. These innovations address the intermittency of renewable energy sources, ensuring a stable and reliable power supply. Energy grids become more resilient, capable of integrating a higher percentage of renewables and reducing dependence on fossil fuels. Climate-resilient infrastructure. By 2040, climate-resilient infrastructure becomes the standard for new developments and retrofits. Coastal cities implement advanced flood defense systems, such as sea walls and tidal barriers, to protect against rising sea levels and storm surges. Infrastructure in arid regions incorporates water-efficient technologies and drought-resistant materials. Green building practices, including passive solar design and green roofs, become mainstream, reducing the energy consumption and carbon footprint of buildings. Widespread adoption of electric vehicles. By 2045, electric vehicles (EVs) dominate the transportation sector. Advances in battery technology, coupled with widespread charging infrastructure, make EVs the preferred mode of transportation for individuals and businesses. Public transportation systems also transition to electric and hydrogen-powered options, reducing air pollution and greenhouse gas emissions. The shift to electric mobility significantly lowers the transportation sector's carbon footprint and improves urban air quality. Global net zero emissions. By 2050, the world achieves a critical milestone: global net zero greenhouse gas emissions. This achievement results from the culmination of decades of efforts in emissions reductions, technological advancements, and policy initiatives. Renewable energy sources supply the majority of global energy needs, while carbon capture and utilization technologies offset remaining emissions. Nature-based solutions, such as reforestation and wetland restoration, further enhance carbon sequestration. The achievement of net zero emissions represents a turning point in the fight against climate change. Ocean health restoration. By 2055, significant strides are made in restoring ocean health. Marine protected areas expand, covering 30% of the world's oceans, safeguarding marine biodiversity and ecosystems. Efforts to reduce plastic pollution and improve waste management result in cleaner oceans. Advances in ocean farming and sustainable fishing practices support marine life recovery and provide food security for coastal communities. Ocean-based carbon sequestration methods, such as kelp farming and artificial upwelling, contribute to climate mitigation efforts. Climate adaptation and resilience. By 2060, communities around the world have successfully implemented climate adaptation and resilience strategies. Early warning systems for extreme weather events are highly advanced, enabling timely evacuations and reducing loss of life. Agricultural practices are adapted to changing climate conditions, with drought-resistant crops and precision farming techniques ensuring food security. Coastal communities employ nature-based solutions, such as mangrove restoration and oyster reef construction, to buffer against storm surges and erosion. Global water security. By 2065, global water security is significantly improved through innovative water management practices and technologies. Desalination plants powered by renewable energy provide freshwater in arid regions, while advanced wastewater treatment and recycling systems ensure efficient water use. Integrated watershed management and reforestation efforts enhance water availability and quality. International cooperation on transboundary water resources fosters equitable sharing and sustainable management of water resources. Carbon-negative technologies. By 2070, carbon-negative technologies become widely implemented, removing more carbon dioxide from the atmosphere than is emitted. Direct air capture (DAC) systems, enhanced weathering, and bioenergy with carbon capture and storage (BCCS) are deployed at scale. These technologies, combined with ongoing reforestation and soil carbon sequestration efforts, contribute to a net reduction in atmospheric CO2 levels. The development and deployment of these technologies mark a significant advancement in climate mitigation efforts. Circular economy dominance. By 2075, the global economy transitions to a circular model, where waste is minimized, and resources are reused, recycled, and repurposed. Advances in materials science enable the creation of fully recyclable and biodegradable products. Industrial processes are redesigned for efficiency and minimal waste generation. The concept of waste is redefined, with byproducts from one process serving as inputs for another. This circular economy reduces resource extraction, lowers emissions, and promotes sustainable consumption patterns. Geoengineering research and governance. By 2080, research into geoengineering techniques, such as solar radiation management and ocean fertilization, progresses under strict international governance frameworks. While these technologies are approached with caution due to potential risks and ethical considerations, they are explored as potential emergency measures to mitigate extreme climate impacts. Robust international regulations and oversight ensure responsible research, testing, and potential deployment of geoengineering methods. Biodiversity conservation success. By 2085, global biodiversity conservation efforts yield significant success. Protected areas and wildlife corridors expand, allowing species to migrate and adapt to changing climates. Conservation programs focus on restoring habitats and reintroducing endangered species to their natural environments. Genetic diversity is preserved through seed banks and gene libraries, safeguarding species from extinction. Public awareness and education campaigns foster a deep appreciation for biodiversity and its role in ecosystem health. Climate equity and justice. By 2090, the principles of climate equity and justice are deeply integrated into global climate policies and actions. Vulnerable communities, particularly in developing countries, receive substantial support for climate adaptation and mitigation efforts. International financial mechanisms, such as climate finance and loss and damage funds, ensure that the most affected populations are compensated and assisted. Indigenous knowledge and practices are recognized and incorporated into climate strategies, promoting inclusive and equitable solutions. Advanced climate modeling and prediction. By 2095, advancements in climate science and technology lead to highly accurate climate modeling and prediction capabilities. Quantum computing and artificial intelligence enable the analysis of vast amounts of climate data, improving the precision of climate forecasts. These advanced models inform policy decisions, disaster preparedness, and long-term planning. Real-time monitoring of climate variables provides early warnings for extreme weather events, enhancing community resilience and response. Global temperature stabilization. By 2100, global temperatures stabilize, marking a major victory in the fight against climate change. The combination of emissions reductions, carbon sequestration, and adaptation efforts successfully limits global warming to 1.5 degrees Celsius above pre-industrial levels. The stabilization of temperatures reduces the frequency and severity of climate-related disasters, such as heat waves, hurricanes, and wildfires. Ecosystems begin to recover, and species previously at risk of extinction show signs of resilience and adaptation. Sustainable urbanization. By 2105, urban areas worldwide are transformed into models of sustainability and resilience. Smart city technologies optimize energy use, transportation, and waste management, reducing urban carbon footprints. Green infrastructure, such as parks, green roofs, and urban forests, enhances urban biodiversity and mitigates the urban heat island effect. Sustainable urban planning prioritizes walkability, public transportation, and affordable housing, creating inclusive and livable cities. Global food system transformation. By 2110, the global food system undergoes a transformation towards sustainability and resilience. Vertical farming, aquaponics, and lab-grown meat become mainstream, reducing the environmental impact of agriculture. Precision farming techniques, powered by AI and robotics, optimize resource use and increase crop yields. Sustainable fishing practices and aquaculture support marine biodiversity and food security. The adoption of plant-based diets further reduces the carbon footprint of food production. Intergenerational climate education. By 2115, intergenerational climate education is deeply ingrained in societies worldwide. Climate literacy becomes a core component of education curricula, from primary schools to universities. Public awareness campaigns and community programs engage all age groups in climate action and sustainability practices. The collective knowledge and experience of older generations are valued and shared, fostering a culture of stewardship and responsibility for the planet. A resilient and sustainable world. By 2125, the world has transformed into a resilient and sustainable society, capable of thriving in harmony with the planet's climate. Innovations in technology, policy, and social systems have successfully mitigated the worst impacts of climate change. Global cooperation and solidarity ensure that no community is left behind in the pursuit of a sustainable future. The Earth's climate is stabilized, ecosystems are restored, and humanity lives within the planet's ecological limits, securing a prosperous and equitable future for generations to come. Conclusion. This vision of the future outlines a path toward a sustainable and resilient world through a series of interconnected milestones. Each milestone represents a critical step in addressing the multifaceted challenges of climate change, driven by innovation, cooperation, and a commitment to a better future.